Hello 6th grade math students, to your first online lesson of the year. We are at a point in this unit on proportional reasoning where we've done all of the sort of instruction and learning new ideas, and I was going to spend these last couple days of the unit practicing. I'll show you how we're going to do that together here in a minute. But your assignment for tonight, which you can tell just by looking at the math blog, I'll show you right now. You're going to go to the math blog every day, like you always do, and click on the date to open the blog entry, and don't forget to scroll down for 5th and 6th period. But when you look where you would normally see the learning opportunity, you see the review for the next test, the review for test 6. That's going to be your assignment for the next couple nights, and then we're going to go through the review together on the videos, which will be posted. I'm not sure if I'm going to post them on Wednesday or Thursday, but possibly Thursday. But in any case, you start working on that tonight, 30 minutes, like you always do. Work on these problems on your own for 30 minutes. Some of them are pretty tough, so if you get to one that you're not sure how to do, skip over it, come back to it later, give it your best shot, and then the videos will back you up when you go through the videos. But start working on that tonight. You'll work on that for 30 minutes tonight. You'll work on that for 30 minutes tomorrow. I'll make that clear in my email to you each morning. And then the key for that computation go is right here, because that computation go is due tomorrow. The notes for today are not typically here. This is a new thing. If you click on the notes sheet, you may or may not want to print this. You can either work from the screen. I've got this all in a Nearpod also that you'll be using, so you decide whether you want to print that or not. But this is the practice we'll be doing together. And then the lesson is right here, and I'm not going to click on it because I actually haven't. I'm making it right now as I'm making this video, so I'll make the correct link to the lesson. It's a Nearpod that you'll be watching, and you'll do some practice and then check how you did. I'll do a little video after each bit of practice so you can compare your work to mine. Okay, the discussion board almost never gets any use. I post a discussion board for each assignment, but as you can see, they very seldom get viewed at all. But that will change starting right now, because I require you to, once per day, this is lesson 612 that we're doing today, click on it and reply. You're going to have to reply to this one because this is the way you're going to tell me your score on the homework assignment that is due today and that we'll be going over together shortly. But you need to, whether you had something to turn in or not, you need to get on here and reply. Make some comment about the lesson, or ask some question or something, so that's the way I'm going to take attendance and check in with you each day. Okay. I wonder whether that will be clear the first time. If not, I'll be emailing you, those of you that do not make a comment, to make sure you understand that that's an expectation. Alright, so let's get into this lesson. That's not it. This is it. We're going to start the way we always start. Not with a do now, because the do now on a day like this would have been to start on this practice we're going to do, but let me just start with the homework that's due. The assignment 6.11. Number 1 is 66 meters. Number 2 is 4 feet. Number 3 is 31.5 meters. Now, if you got all three of those right, you can skip ahead. You don't need to watch the rest of this section of the video. If you missed any one of those, you should keep watching, because I'm going to do them all. This is how I'm going to give you the feedback that I would normally give you by going over your work. Number 1, we were comparing the sides of two similar pentagons, and I think the proportion I would have set up for number 1 would be 17 over 51 is equal to 22 over x. Comparing the smaller pentagon to the larger pentagon. Of course, as we talk about often, there's many different ways of setting up that proportion. As long as the cross products are the same, then you have an equivalent proportion. Speaking of the cross products, if you solved it using cross products, it would be 22 multiplied by 51 equals 17x. And 22 multiplied by 51 is 1020. equals 17x. And the reason we write the cross product equation, it will guide our work. Now I divide both sides by 17. And I did it wrong. Not 1020. 1122, Mr. Colby. 1122 divided by 17 is 66. 66 equals x. You could also have noticed a scale factor of 3 if you happen to know that 3 17ths is 51 and apply that scale factor to the 22. Problem number 2, you have similar triangles. They're not drawn nicely, they're not oriented in the same direction, but if you compare side TS, the one that's x, to side VW, the one that's 19, that makes sense because those look like the two shortest sides. And that would be equal to the ratio of the 8-foot side to the 38-foot side. There's a nice scale factor here, times 2 going that way. Of course, I would rather have it going this way because I'm trying to get to x. So if it's times 2 going that way, it's multiplied by the reciprocal of 2, or 1/2 going the other way, or dividing by 2. Half of 8, or 8 divided by 2, is 4. And so x equals 4. And when I put the 4 on side TS, that looks like a reasonable length for that side. I should have mentioned that for the problem number 1. Number 3, it's hard to see that triangle JLM when it's inside of that other triangle, so if it helps you to draw it outside of the big triangle and then put the dimensions on it. The big triangle is JKN, like this, and this side is 36, and this side is x. We're trying to find x. So 8 over 36 equals 7 over x. No nice scale factors. This one kind of forces you to use cross products. 8x equals 36 multiplied by 7. So 8x equals 210 plus 42, 252. Divide both sides by 8. Doesn't come out to a whole number. 252 divided by 8. 3/8 and 25, because 3/8 is 24. Subtract to get a difference of 12. 1/8 is 12. 1/8 times 8 is 8. So 12 minus 8 is 4. Decimal, bring down the 0. There's exactly 5/8 and 40. So 31.5. It makes sense that it would have been 0.5 because if I'm counting eighths and I have 4/8 left over, that's half, right? 4/8 is a half. One mistake students sometimes make is they subtract the 8 from the 36, but then you'd be looking at a side of a trapezoid, not a side of that big triangle. You really do want that whole 36 when you're comparing these similar triangles. Okay.